gentlemen, my name is Gillian Sheldon. I'm Business Development Manager at Ontario Centres of Excellence. Welcome to the Innovation and the Future of Manufacturing panel session. Today, manufacturers are faced with challenges of a strong dollar, rising business costs, and the need to innovate. Canadian manufacturers are reinventing themselves to take advantage of the vast opportunities of a global marketplace. Streamlining to become more vertically integrated is enabling Ontario's manufacturers to innovate all along their value chain, to step outside their comfort zones and explore manufacturing opportunities in new sectors and processes, including biomanufacturing, environmental products, and lightweight composites. Today, we have a great opportunity to learn from this panel of industry experts how manufacturers are transforming the technologies they're utilising them, and what the future will look like by utilising these. There will be a Q&A period at the end of the session, and we ask that you hold your questions to this point. Also, if you're tweeting today's session, please use the hashtag OCE Discovery. I would now like to introduce you to the moderator for this session, Mr. Ian Howcroft. Ian is Ontario's Vice President for Ontario Division of Canadian Manufacturers and Exporters, or CME. He's responsible for all aspects of CME's Ontario division, including business development and policy, and is the chief advocate for Ontario. CME is a leading national employer or association with a membership of small, medium and large companies from all sectors of manufacturing. Member companies produce approximately 75% of Canadian manufactured output and are responsible for 90% of Canada's output. Welcome, Ian.
Thank you very much, Gillian. Very, very pleased to be here to moderate what I consider an extremely important and apropos session on innovation and the future of manufacturing. Of course, that's something crucial that CME is dealing with and working on. We have a rising dollar, rising costs. It's imperative that companies deal with that by improving productivity. And one of the best ways to deal with that is to focus on innovation, take advantage of opportunities, identify new customers, identify new markets, and it's important that we all find collaborative and cooperative ways to deal with that. So, as I said, I'm very pleased to be here to moderate today's session. I have a few slides that I'll go for to hopefully set the context of what the panel will be talking about. But first, I would like to introduce the panel that we have before us and thank OCE for identifying an excellent group of experts for us to hear from. First, we have Dr. Jacek Marnik, and I apologize for bastardizing your name. He's the president and CEO of CTT Group, Canadian Centre of Excellence for Textile, Geosynthetic and Flexible Material Technologies. This group is proud to be a major catalyst in the textile, geotextile, and polymer industries, devoted to improving industry productivity by means of technology transfer, research development, testing, and exchange information. Dr. Mlinárik has vast experience in development of innovative technologies and their transfer into commercial applications. He works internationally, teaching, researching, and consulting about value-added textiles, technical textiles, geotextiles, and geosynthetics with all types of applications. Recently, he was involved in the foundation of new companies based on new innovative technologies of value-added textiles developed with CTT Group in partnership with textile partners. They include the Transtex Technologies, which develops antibacterial textiles. Our next panelist is Doug Angus Lee, and he's with Rapid Prototype Account Manager at Javelin Technologies. He's an expert in 3D printing and rapid prototyping at Javelin, Canada's leading 3D CAD solutions provider. Doug has a passion for technology and business communications that extends across his two-decade career in hardware and software sales management. He has also worked in business-to-business media, including website and video production, preceded by a business degree from Ryerson University in Toronto. What Doug most loves about 3D printing is that it enables innovation so Canadian companies can be more competitive in a global economy, and of course, the cool engineering models and parts he gets to make as part of his job. Next, we have Michael Gardner, who is the Director of Industry Solutions at Siemens Industry Software Limited. Michael is the Director of Industry Solutions. In his current role, he has been using his experience from Siemens' extensive international customer base to provide guidance on digital product development and manufacturing IT to Canadian companies. For over 15 years, Michael has helped leading manufacturing firms add software capabilities that enhance innovation and optimize production. He's a specialist in digital lifecycle management and leads teams that have successfully served clients competing in the global automotive, high-tech, machinery, consumer products, aerospace, and defense industries. He has a Bachelor of Applied Science in Mechanical Engineering from Queen's and Kellogg Schulich Executive MBA. Our last panelist is Robert Little, Vice President and Country Manager for Altair Engineering Canada Limited. Robert joined Altair in 1988 and over the next 15 years gained progressive responsibility for corporate sales, support, and marketing activities as Altair grew to become a global provider of computer-aided engineering and simulation software. During this time, he had the opportunity to work with numerous manufacturing clients throughout North America, Europe, Asia, gaining first-hand knowledge of the emerging global competitiveness that North American manufacturers now face. In 2005, as the senior Canadian at Altair, he was asked to form Altair Engineering Canada, the company's 14th global subsidiary. The focus on Canada allowed him to connect with Canadian universities, government organizations, and private manufacturing companies in a number of industries. He currently serves on the board of Auto 21 and NCI Automotive Research Initiative and ShareNet, the high-performance computing consortium serving in southwestern Ontario. So we have an excellent panel that we can hear from shortly. I just want to quickly go through a few of the slides that I have to hopefully set the context. The slides are available for everyone, so I'm not going to go through them in great detail, just to set the context about what CME does. One of the things we always want to make sure people are aware of, and I think the people in this room know, is the importance of manufacturing. We've gone through the worst recession in 100 years, and we have an image issue, an image challenge. People have to realize how important manufacturing is to our current situation and to our future. It's a $540 billion, $270 billion economic output driver in Ontario. We have about 1.75 million direct jobs in Canada, about 800,000 direct manufacturing jobs in Ontario, and as important or more important, there's probably another 3 to 4 million jobs that are indirectly dependent on manufacturing. Very highly diversified sector, highly integrated still with the United States. 85% of commercialization in the private sector takes place by manufacturers. And when you take in the full multiplier for the economic contribution, it's about $1.5 trillion, because every dollar invested in manufacturing generates about $3.50 in total economic activity. Another message we always want to make sure the government understands is that jobs depends on profitability. It's crucial that companies are making a profit, and we have to do everything we can to make sure people understand that and what the value is. We've seen great improvement since the depths of the recession, but it's still a lot of uncertainty. There's still a lot of challenges out there, and manufacturing will continue to go through its evolution and transition to become what we're classifying, or many classify as the advanced manufacturing sector. European debt problems, slowdown in trade, slowdowns in China, reduced demand for commodities is having a huge impact. The political situation in the United States, the unrest in the Middle East are just other challenges that we have to deal with. And the growing debt, both governments and individuals, is having an impact on how things are moving forward. This just depicts, this graph, how manufacturing has done over the last 10, 15 years. Things were going through normal business cycles, and then we saw what happened in 2008, 2009, dropped off dramatically. What we have to deal with now is the opportunities. We have to embrace innovation. We have to embrace productivity to allow us to continue to be globally competitive because countries and competitors around the world are doing everything they can to make sure that they're going to be successful. Competition will continue to increase, both for customers and for product mandates and for people. That's another key issue that we're dealing with, is the crisis around skill shortages. We need to have the right skills if we're going to be successful. The value of the dollar is something we continue to hear about. Not only has it been extremely high in relative terms over the last 10 years, there's been a lot of volatility, which also causes some challenges. There's been consolidation during the recession, and as I said, we saw orders drop 30–40%. Some companies were not successful. And since then, companies have been a little reticent to make some investments because they want to see more certainty, so we have to work on that. But notwithstanding all the negatives, there's a lot of great opportunities, a lot of great challenges that companies have been successfully dealing with. We depend on several themes, several key drivers. We've surveyed our members, and we've been holding roundtables around the province. And what the companies need to do is to find ways to build their business, to identify new customers, new sectors, and new opportunities, win global mandates. They need to differentiate themselves, show why they're unique, what contribution they can bring to the value chain, the supply chain. They have to increase their productivity. They have to invest in technologies and be as innovative as possible. And again, to ensure you're maximizing this, you have to have the skill sets, the competencies within your workplace if you're going to maximize those opportunities. Investments have to be made to access new markets, new products, new processes, and we're trying to help our members do that. And a key part for us is to make sure that we're working in partnership with key organizations such as the Ontario Centres of Excellence, Colleges of Ontario, and other academic institutions. Huge opportunities exist in Canada with the oil sands and other energy opportunities, the Ring of Fire in Northern Ontario. Across North America, there's lots of opportunities, and around the world, we have to help our companies, our members, access some of these new markets. That's why we've been involved in supporting the European trade negotiations, new supply chain opportunities to be globally competitive. These are some of the policy issues that we're dealing with. We need to have a proper world-class regulatory system and a tax system that allows companies to invest in technology and to reap the benefits of innovation. And we have a strategic initiative, our action plan for moving this forward. Again, the image of manufacturing has to be better addressed. We have to get the accurate perception about what those opportunities are to encourage young people to follow a career that includes manufacturing, to get guidance counselors and teachers to understand what manufacturing is all about. We want to build a modern manufacturing workforce. We want to support the R&D and innovation that's required to be successful, create that regulatory system, and improve our connections in Canada and around the world to become a global player, build on the successes that we've had, and ensure that we can continue to invest in our infrastructure, which will support what we're doing. So hopefully I'm a quick talker and help to set the context of what we're going to be talking about for advanced manufacturing, the opportunities around innovation and technology. And I've introduced the panel that we have, and I'm very pleased to call our first presenter to the stage to make his presentation. Dr. Mlynarczyk, can you please come forward and provide your presentation?
Thank you very much. Thank you very much for introduction, and thank you very much for invitation to be part of this panel. I am going to talk to you about some strange material, and I would like to understand before, what do you think about the material? What do you think about textiles? What do you think about textiles? What is your image of textile? Huh?
Old economy.
Yeah. All of us, we think about textile as apparel material. And it's true that for apparel textile, probably we do not have many possibilities here in Canada. However, what I work with, it's technical textile. I will give you, for the beginning, some information about market, and then business people will understand what huge opportunity we have in front of us. The rise of innovative textile began only 12 years ago. In fact, 12 years ago, we started to think about the different application of textile, and we name them today technical textile. The technical textile consumption in 1995 was $78 billion. What is predicted in what was for 2012 was $133 billion. And what we expect to have in 2020, it will be $175 billion. So you could see right away what huge increase of opportunity we have in this development. So my research and innovation center, we focus really on advanced material based on textile, and I'm going to present to you a few examples of amazing development which we did, just to develop your imagination, and then at the end I'm going to show you how we do it. Okay, so let's start with a miracle of textile. I believe that this is an excellent example, one of Canadian development of camouflage material. We develop it with Canadian companies in collaboration with National Defense. And so you can see how we can protect. And Canada today is one of a leading company in protective textile materials. We work with in Canada and also with United States, and Canadian companies are also very visible in all over the world. So, but to develop this type of material, to camouflage people and our soldiers, to protect them, we need really to develop a specific pattern. And you have this type of a pattern which change in function where the soldier is. The next one is really transportation. Could you imagine transportation as a textile industry? Today, Streamlining is an example, and there is a lot of development of replacing fuselage and hull plane with new textile materials and composite material based on textile. So we cannot see this type of material without this type of development, without textile. And when Peter talked yesterday about asteroid development, could you imagine that I had a question from Canadian Space Agency to develop protective material for the astronaut who is going to land on asteroids alone and to be protected for long term, to explore all what it is on this asteroid. So you could imagine what we can do, and we work on this type of project. Then the next one, oops. Can I have a next one? Okay. Now, there is all mining industry here in Ontario, so development. So you can see here innovative textile as geosynthetics, which can really protect our environment. You have on the left side, you have a destroy after mining, and on the right side, you have an application of textile to protect our environment. This is a geosynthetics, geomembranes application. Now, I would like to have a video here. Now, there's even for apparel, we work with the text. I would like to show you a short video. We don't see. Sorry for that. I would like to show you here. I would like to show you here a development which we did with American company to protect our children against UV protection, against UV exposure. What's happened that there are people playing around, small kids playing around a swimming pool, and they are not protected. So we can have a special suit including textile fibers and some sensors which can detect a level of UV exposure, and then mom can see that it's too much at this moment, so the kid cannot stay longer in this type of environment. So can I see next slide? So there's an apparel application. This is not our major interest, but we add value into apparel application as well. So. And then here you have I talk about airplane and the intelligent seat belt. We work with one company who wants to develop a new way of connecting our seat belt, buckle up, and the pilot and crew know that the person seated has buckle his seatbelt. It's much easier for them, much less work for them. And in the future, what we expect that the new plane will have a lot of intelligent textile inside, which will protect people and help crew to really control what's happening inside. Also, the development of intelligent textile, heated materials, a lot of new development, Thermastrom, heated scarf for, and also all heated material which can be implemented into boots, other protective apparel. Our strategy, and this is a really vision what we do and how we work, our strategy is really to cooperate, to innovate. I do not believe that one company can develop product without understanding a chain of value. So what we try to do, we always talk to the end user at the beginning, then manufacturer, and then the supplier of material or fiber. So here's the example of a consortia which we develop. We have a few partners Plastifil, manufacturer of fibers, Matador, manufacturer of textile, Pureless, users for protective materials, Maison Pépin, people who use the textile for construction, and CTT Group, a research center. And with this consortia, we develop a new insular material for durable construction. So, research, innovation, collaboration, textile enable innovation. Thank you very much.
Thank you very much. That's pretty good. Thank you very much. Could I now ask Angus Lee from Javelin Technologies to come forward? Good morning, everybody. Thank you very much for coming today. I want to start by telling you a couple things that you probably already know. First of all, we're here today because we realize that we compete in a global economy, right? No longer are we competing against the guy down the street or the company across town. We're now competing against thousands or hundreds of companies around the world. And so to compete in that environment, we need to innovate, and we need to innovate faster and better. And that's what we do at Javelin, so that's what I wanted to talk about today. When I say faster and better, what we need to do is and you're going to hear me say this a lot today, we need to design better products, we need to get them to market quicker, and we need to reduce our costs in order to be competitive. So my first slide here is sort of the mandatory, this is about Javelin slide, and I'm not going to tell you much about Javelin because you can read the slide, except to say that back in 1997, our founders realized that to be able to do those things, to design better products, to get them to market quicker, and to reduce our costs, they needed we needed to embrace 3D technology. And so we became SolidWorks vendors, and since then, all of our business is wrapped around that 3D CAD and CAM piece, if you will. Most people, when they think of 3D CAD, they think of pretty pictures and things spinning around on the screen. And that is certainly part of 3D CAD and CAM software, but it's only a very small part. Most people don't realize how 3D CAD impacts every part of your business and allowing you to be more competitive. So to that point, let's talk a little bit about 3D CAD and how it does affect your business. This slide is a little bit out of date, but really I want to break it down into 3 areas, and there's a 4th one we should add, and some of my colleagues will talk more about that in a minute. But first of all, the renderings is what everybody thinks of as when they're thinking of 3D CAD. By the way, just to take a bit of a step back, this may seem obvious to a lot of people here, and sometimes it seems obvious to me. And I think, well, of course, everybody uses 3D CAD because I work in the business all day long. But recently, some new data came out that shows that only 50% of people who are designing new parts and new products are using 3D CAD. So that means half of you in the room, if you're designing for manufacturing, you're still working in 2D. And if you want to be competitive, and if you want to be here 5 years from now when we have this conversation, you need to embrace 3D technology. So most people think of 3D as these fancy things that spin on the screen. But our clients, yes, they have these renderings, 3D renderings of the parts that they design or the products that they design. Those things are connected to every other part of the business. So they're using those designs for their marketing. Those renderings are ending up in their advertising. Those renderings are ending up on their website, in their pay-per-click ads. They're able to create and use those images of their products before they're even manufactured, and in their documentation. So things like their user manuals, their safety brochures, assembly instructions, all those things are being generated very quickly and automatically because that data is already in 3D. Second is their business processes. And this is really key. That when you design in 3D, everything in your design is a separate entity. Everything has a mass, it has mechanical properties, it has a part number, and everything goes into your assembly is all connected to other parts, or can be all connected to other parts of your business. So when I design something and I need 50 1.5 inch number 8 screws in that part, then my ERP system knows that when I design it, and so does my ordering department. And when marketing says we need an initial run of 1,000 pieces, then
that's also integrated so that they know how many pieces to order. And that's true, so it also ties into the financial systems. Everything, you know, and when you're designing in 3D, you're dealing with objects, you're not dealing with a diagram. And where I specialize in the 3D printing side of things, when you're working in 3D, you're also able to prototype, make very accurate and detailed models of your designs. We're going to talk about that more in detail in a minute, but essentially what that allows you to do is to get is that better part or better products that I talked about, because you're able to engage more people, you're able to get feedback on your designs internally and externally. And in our world, we always talk about things being more sellable. And that's what we're able to do by creating accurate and realistic prototypes. So again, these three things allow you to design better products, get them to market quicker, and reduce your costs. Again, that's how we're going to be more competitive. So some people use the term when we're talking about 3D printing of the next industrial revolution. And I absolutely think that that is correct. I mean, back in, you know, the advance of the invention or implementation of the assembly line changed the way that manufacturing works. 3D printing is going to change the way manufacturing works in the future. We, you know, back when the web when the web took off, it gave us the tool for everybody in this room to become a publisher. That was something that only a few of the biggest companies in the world were able to do before that. Well, with 3D printing, we're all able to be manufacturers. So again, democratizing manufacturing, bringing it down to the level where everybody can manufacture their own parts is really key. And so what we do is we help designers perfect their ideas, we help manufacturers evolve the way they make things, and we transform the way individuals and teams organizations work. So how do we do that? So for designers, you know, we can, again, we're very easily and quickly able to take somebody's design and turn it into a real world product. That provides important feedback to designers, allows them to make decisions quickly, allows them to identify errors, but mostly it's accelerating that design cycle. So you're able to design products quicker. One of those key three things that I talked about earlier. For manufacturers, the advent of 3D printing has really turned manufacturing on its head, and that's what we're here to talk about today. So all the things that used to be the most difficult things to do in manufacturing, and therefore the most expensive things, are what 3D printing does really, really well. So part complexity. If you had a really complex part, it would be more expensive to manufacture. But a 3D printer doesn't care whether you're printing a solid block of something or a very complex, intricate part with lots of details and moving parts. It's all the same. So there is no deterrent or no extra cost to printing, to manufacturing complex parts, and low volumes. So there is no economies of scale with 3D printing. So you don't save money by printing a lot of parts, but you also don't lose money by printing very few. Again, completely transforming that manufacturing paradigm. And working with organizations and teams, we help them by helping them to iterate their designs much quicker and more often, identifying errors, and collaborating better. Because there's nothing like having a real world part in your hand to hold and to look at and to test whether it fits with other parts and whether it works the way you want. So again, those three things, we're able to design better parts, get them to market quicker, and reduce costs. And in general terms, these are the things that we're doing with 3D printing. We're going from concept design, so is that what I think the part should look like? Is it look like I want it to? Does it do basically what I want it to do? Functional testing, so we're able to take those and put them into real world environments to see if they perform properly. And also we're getting more and more into manufacturing. And so very quickly, I'm going to go over this slide pretty quickly. There's a whole bunch of stuff on here about some of our clients. But just to reiterate, you know, designing products better. Audio Products International, as an example, was able to increase their output of new products by 100% by implementing 3D technologies and 3D printing. Burlington Technologies, 50% faster changes and fewer design errors. And Ducati motorcycles reduced time to market by 71%. So again, designing better products, getting them to market quicker, and reducing your costs. So what we can do is we need to innovate. We need to lead our industries, and we need to support innovation both internally within our organizations and externally. Don't forget that you can help support your customers and your suppliers by helping them to innovate as well. And we need to adopt 3D technology in order to compete globally. Thank you.
Thank you very much, Doug. Michael Gardner will now make his presentation.
Thank you. So my name is Mike Gardner. I work for Siemens Product Lifecycle Management software division. We design and specialize in 3D design, simulation, manufacturing, and collaboration software. Siemens is well known in the manufacturing industry for automation, drive technology, controls, and Siemens actually added our division as a result of an acquisition of UGS PLM Solutions in 2007. And the vision is really around helping industrial customers increase their innovation and productivity by linking the virtual world and the virtual environments that we create in the software division to the physical factories that Siemens is helping their customers develop. So if we roll it back a little bit, I think every operations management course in the world will talk about Kaizen, right? The idea of continuous improvement. And one takeaway about looking at Kaizen and the strategies and the leading companies is that you can gain an enduring strategic advantage from improving your process, your manufacturing process. So it isn't just about the product, but it's also the way you build that product, right? And so I'll take you through a few of the things that manufacturers are doing. There's lots of opportunity for innovation. Products are far more complex than they ever were. If you look at an automobile these days, look at the software components, the electronics components, and they're getting developed in half the time. The automotive industry has really been an innovator in this area. Mass customization, new materials, composite materials, new textiles, higher speed machines, make it a lot more challenging to achieve the precision and the quality which is expected. And then you have this explosion in additive manufacturing. Similarly, manufacturing processes, safety is a given, right? They have to be leaner, they have to be faster, they have to be higher quality, and they also have to be environmentally sustainable. So manufacturers are really struggling or really challenged with the number of variables that they have to optimize. And so, what do they do about that? And this is where simulation can come in. And this really helps innovation. There's a number of different areas that you can look at, right, to address the various factors. One of the areas is process modeling and validation. So taking your manufacturing process, looking at the sequences, looking at the performance, looking at different ways that you can approach a different part manufacturing, assembly manufacturing, or process problem. Certainly human factors and ergonomics. People are definitely a big part of the equation, right? But and safety is an important thing. So you can take a person, you can capture their motion. We're using commercial off-the-shelf technology like the Microsoft Kinect. So, you can convince your boss to buy an Xbox for you while you work on these types of things. And you can look at, looking at logistics and the way that somebody manufactures something in a safer way. You can also look at, the fatigue. You can test stresses and things like that. So again, you're looking at the people and using digital technology to help. Robotics and automation are a big part of, obviously, modern manufacturing. Simulating those processes, looking at safety zones and timing and coordination so that you can speed up cycle times. And if you want to look at kind of the bigger picture, you can also look at overall logistics and throughput. So the entire factory, the combination of work cells, different options for that. So one of the key things is that obviously if we do this in a virtual environment, you're allowed to evaluate scenarios that you might not be able to do if you go through a traditional process or you do some more prototyping. And what that really allows you to do is really try different things. I mean, one of the things we talked about in yesterday's morning session is about kind of enhancing the culture of innovation. And one of the challenges around that is having the freedom to make mistakes, right? Well, that's a lot easier to do in a virtual environment. You can try different things and you can test different things. And that will allow people the freedom to try innovative things, look at different machinery, look at different processes, look at some of the new technologies or the new research that is coming down the pipeline and see how it might apply to your process. So if you look at the extreme example, you can actually build an entire factory within the computer using the software. You can simulate and optimize operations before the foundation is even poured. So one idea of Kaizen is the idea that, on the shop floor or on the production line, they give the workers a rope that they can pull, and that signals that there might be a problem that we have to address, right? And then they take a look at it, and hopefully they address it before they have to stop the production line. Well, in a virtual factory, you actually take the factory to the workers, right? And those workers can be your global partners. They can be parts of your division that are halfway across the world, right? So they can point out the opportunities for improvement, right, by taking the factory to them before you've built the line, before you've invested in equipment, before you've made any capital expenditures, right? So this is a way you can kind of get ahead of the game, right? And the importance of that, so this is how you kind of really change the paradigm and turn it on its head a bit, right? And the beauty of this for Canadian manufacturers, is it allows you to experiment, and it allows us to look at all the different possibilities without spending large amounts of capital, which we know is a lot more tight these days. So, so that's it. Thank you for letting me present.
Thank you. Thank you very much. Thank you very much, Mike. Our final speaker for the panel is Rob Little from Altair Engineering. Rob?
Thanks. I was nervous as hell.
Thank you, Ian. My name is Bob Little. I'm with Altair Engineering in Canada. I've been asked to talk about HPC in manufacturing, and for those of you who don't know that much about high-performance computing, I'd say it's very nicely arranged here in terms of what people have talked about, because a lot of the simulation and modeling or virtual testing, virtual prototyping, for it to take place really successfully, you need more accuracy in the algorithms and the software that are being developed. And as those algorithms and software tools are developed and enhanced, unfortunately, they require more compute power to run in the same time that the previous versions ran in. So the solution is high-performance computing, meaning we need more CPU cores in our machines when we're running. And so I think for a lot of people at the conference today, you read about it constantly, and if you go into the different high-performance computing consortia in Ontario, you'll see huge consumption of compute power by astrophysics and atmospheric physics and genomic research and life sciences and environmental sciences and all these things. But even amongst the HPC people in the province and the country, you don't hear about manufacturing that much. And I think that, in a way, is a bit of a problem, because it's a perception that, or it leads to a perception that there's not much HPC going on in the manufacturing sector. But the truth is, for people like me or the other people on the panel, we do see it quite a bit. It is a source of competitive advantage, though, so the manufacturers don't want to talk about how they're able to accomplish all the good things we're discussing. So I wanted to position HPC in that context, and I think it'll allow us to discuss it in a little more detail. My first slide, please. Cue. Whoops. Can we go back once? Thank you so much. So briefly about Altair. Altair as a company was started, the headquarters are in Michigan. It was started in 1985. And our role in life really is to impact the design process and to allow more advanced simulation and more accurate simulation to take place as early on as possible. And in Canada, we have about 60 manufacturing clients, ranging from OEMs in the aerospace and automotive industries down to, say, tier 1, tier 2 suppliers. So a nice mix in a variety of different industries. This slide represents the makeup of high-performance computing amongst our customers. And when I say no HPC, what I mean is they're limited today to using a desktop machine with 4 CPU core, okay? Which is nothing to sneeze at. For most of us on our desktop, we probably have something smaller, but it's not HPC. I think if you can buy it at Future Shop in the basic context. But the nice thing is, amongst the rest of our clients, over half of them have HPC systems that go up to 100 CPU cores, which still pales in comparisons to what you read about in the paper in terms of the 1,000 core, 500 core, 5,000 core CPU core machines that are in use in some of the other industries. But nonetheless, it's high performance computing and it makes a big difference. And then we have about 15% who are over 100 core. And I'd say this ranges typically 500 to 1,000 CPU core. So from a media standpoint, it's not exactly glamorous, but the truth is it gets the job done and it gets it done really well. And if you think about, well, what would you use 500 CPU core or 1,000 CPU core for? Really, it's crash simulation with enough accuracy that you're really only going to do one physical test, or it's airflow simulation over aircraft wing, or in the cabin, or over a high-speed train, not like our trains. So that's the context, and it is happening. So a little bit to touch on what the other speakers have mentioned. Well, why is high-performance computing and simulation important early in the process? So if I break down the product development process into concept design, detailed design, physical testing, and validation, the concept design phase is really, honestly, the most exciting for any level of innovation, because you have the most freedom to explore and try different alternatives and what-ifing and all that fun stuff, okay? And it's very intense and it's very hard work. And it's got to be done correctly. The problem is the knowledge you have at that stage about the ultimate performance of your product is pretty limited on using traditional methods. So that limitation makes it it's an opportunity for innovation. And with high-performance computing and simulation, what it has is the ability to really increase and improve the amount of knowledge you have about how that product's going to perform, which enables you to make better decisions early on during the concept phase. And that concept phase is really important because, honestly, there's been a number of studies that show a great deal of the cost of that product and the manufacturing decisions and everything downstream of it is locked in during the concept design phase. So ultimately, you're able to make decisions more completely, sooner, and also, I think, the most important, with the greatest confidence possible. And it's happening today. In different industries, you'll see companies doing tests that virtually that used to be done physically. Bird strike, bird ingestion for the aerospace industry. Crash, everyone has a cell phone. Our software is used to simulate any of us dropping our phone, and 10 years ago, it was done by building a prototype and dropping it down a tube. You can imagine how much longer that took each time. So a lot's going on in the industry. 3 short examples. If you take a look at these images, and I apologize if they're pretty engineerish, but the top one is a leading edge wing rib for the new A380. And there's a lot of material there. That big panel, forget the little lines and stuff. But the bottom one is a redesigned rib for the same purpose. I think you can imagine if you came out of nowhere and brought that bottom design into a group of aerospace engineers and said, we want you to put this in your plane on the leading edge, as opposed to that old design you've been using for 30 years, most of them are going to look at you like you're a crazy person. So the fact is, in order for that to happen, you have to have a lot of simulation happening very quickly and early on to convince people it's going to be okay. And by the way, it's got to pass certification for a number of different things when it happens. But this is in the product, and it's as much psychology as it is engineering. But it's done because of high-performance computing and simulation. And the same thing goes in the car industry. Again, if you take a look at the top design for what's visible, there's more substance and mass to that top design than there is in the bottom. But in fact, it's not as structurally strong, and it's using a lot more material than the bottom design. And in the end, that's what the innovation and the competition's all about. And the last one I have, my Canadian example from Van Rub Kirchhoff. So similar situation for them. So in the end, simulation and high-performance computing are really a key source of competitive advantage for manufacturers who embrace them. It's a bit of a religious thing. You either have to believe in it or not, because there's a lot of psychological roadblocks. Physical testing, honestly, in the top companies is used now for validation, certification, and that's it. And the last thing is getting that design right conceptually during the concept phase before you move into detailed design, and then any type of physical prototyping is the absolute key. Thank you.
Thank you very much, Robert. We've had 4 very different presentations, yet each one had some common themes, and they were all complementary. We built in some time for some questions, but before I go to the audience, I would just like to turn back to the panelists, starting with you, Jacek, to see what your thoughts were on the other presentations, any questions you might have to pose.
I found exciting both three presentation here. What really is interesting for me that Bob at the end talked about weight reduction, and this is what I am talking about the textile as a base for the future materials. And so it's in a certain way, I understand we need to develop some type of design process, but we need to talk always about the performance of materials, and this is why you confirm what I'm talking about, the future of advanced materials based on textile. Absolutely amazing.
Thank you. Doug?
Yeah, I thought all the presentations echoed some common themes, and that was basically embracing the technology that's available to us to be more competitive and more innovative. And so I thought that it was a good representation.
Thank you.
Yeah, I mean, to echo what everyone else said, yeah, it's very interesting in terms of the different approaches. Some of us are kind of colleagues or peers and partners and competitors in the same industry, and our observations tend to converge. Certainly the use of new materials, though, is a big challenge, like composites and textiles, and incorporating that into design and process is, I think, a huge opportunity.
Yep. I think one of the biggest challenges we have is it's psychological, and for any of us who study in engineering, we seem to be missing the psychology courses, but it's absolutely about confidence and psychology to trying to take the innovative steps, and honestly, the burden's on us to try and facilitate that. So.
Good, thank you. Some more provocative thoughts to hopefully get the questions from the audience. We have 2 microphones set up. If I could just turn now to first question.
Good morning, people. My name is Mike Rudnicki. I'm from Thunder Bay. I have a question for the entire panel, and probably something that everybody else is curious about here. When I went through the introduction of the discovery and listened to the presentation, I was a bit overwhelmed because I'm feeling like we're really at our infancy here for a lot of us and for a lot of our companies. So if we want to advance into advanced manufacturing, which we're presently working on in Thunder Bay, and we want to sort of move forward with the future and not feel like we're very antiquated and so on and so forth. I know there was a question on 3D printing, and there was the advanced computing and so on. What would you say would be the best high value added at this point in time to move us, who basically live, we don't have the resources that you have in Southern Ontario, put it to you that way, for us to be able to bring advanced manufacturing and technology into Thunder Bay? What would you recommend would be the best direction to go, or the best avenue to follow from that perspective?
Thank you. Excellent question.
Yeah, it's an absolutely fantastic question. I agree. I would say, first of all, I would like to understand what are really needs in Thunder Bay area. I always believe that the most important element in all innovation process is understanding of needs and people who are in the area. So I use the word which is end user. For me, you are an area is end user, understanding what are the needs, and then we can develop a all cooperation process, which from cooperation to innovation. And I believe, as I said at one of my slides, we cannot develop anything if we do not have a chain of people involved.
If I could just talk, we just are working on a project right now, which I think addresses exactly your point, and it's actually with Canadore College in North Bay. I talked a little bit about collaboration and supporting innovation, what they're doing is they're setting up an advanced manufacturing center, and they're partnering with businesses to bring those businesses into the center and allow them access to resources that they couldn't afford to have on their own. Because I understand you've got, there are small businesses that just can't afford to invest in that kind of technology. So I think it's a great way, if you get your local community colleges or universities to partner with you, it's a great way to provide those resources and also student resources to help out local companies as well.
Yeah, I agree. I mean, the partnership between the institutions, I mean, our educational institutions in Canada are world class, and so we should definitely take advantage of them. And, location is less important because of things like the internet give you access, and the benefit to that is if you develop something that is truly unique and differentiated, wherever you are, it can get global exposure, right?
Yeah, I agree with what's been said. I think it's really important to ask questions, and we come and we talk about all this stuff, but the fact is, it's not that hard to explain. And I think, I mean, at Lakehead, there's excellent people to talk to, but equally, I would say, contact someone if it appears somebody's in the business that you need help from. Should ask, because if they're not willing to help educate you, I mean, our average user group size for our software in Canada is between 2 and 3 people. So we're not dealing, I mean, okay, Bombardier has 400 people, fine. But the average is pretty low. So it's SMEs, small, medium enterprise we're used to dealing with. And there's a lot of educating that goes on, and most of us enjoy that. And we're not asking for something back. So I would say start asking questions, because if you find the right people, you should be able to begin understanding what you need to get started.
I just want to add one more thing to that, one more question to that, and that is this. If you look at the technology that's existing around us today and the directions that people are going, especially in manufacturing, not necessarily in advanced manufacturing, what would you eliminate as probably the least progressive manufacturing to become involved in? Just as an example, galvanizing, aluminum castings, what would you say would be the direction you don't want to go? Very briefly.
Mike wants to.
I'd say you want to focus on high value content. So, if you're competing on the basis of labor rates and materials, I think you're going to find it a lot more challenging than if you're working on high value, more sophisticated systems.
Yeah, I would say it's not a question of elimination of less interesting manufacturing process. I think it's and I will give you an example of one of my partner, client, customer, and he always says that if there is no market, if there is no client, there is no business. So you need really to, even if sometimes you think it's not interesting. When I start textiles, there's nothing interesting in textile. They are so interesting, so many opportunities. So sometimes you need really to see where's your niche, where are possibilities, where maybe there are some vacuum in the one market which seems to be absolutely not interesting, and you are going to go there and specialize in this direction.
Thank you. Any other questions?
Manufacturing and Appliance Park with GE, some of the work that Apple's doing, some of the GE specialized manufacturing activity. I know in downtown Toronto tonight there will probably be hundreds of 3D printing meetups where people are just sharing information and getting together in a garage, and Silicon Valley kind of analogy today. So I really see a lot of excitement about the future of manufacturing in the US and online, and I'm not sure I heard that today in your presentation, so I'm going to ask you, are you excited about manufacturing, or are you worried about it in Canada?
I'll start. I mean, I think everybody has healthy skepticism about the future because of the challenges. But we did a management issue survey this year, and the overwhelming response is that our members are very optimistic about the future, particularly over the next 3 to 5 years. I think there is a confidence. I think there's a psychological issue we have to continue to deal with. But overall, I think there is a recognition that we have been successful, we can be successful, but we can't take anything for granted. We have to move forward, and we have to do certain things. And I think part of what we're doing is what OCA has put together on, today and yesterday for the Discovery Conference to deal with these issues, to share best practices, to deal with the issues of the how do we help the person that raised the first question as to what do they need to have the support and understand what resources are available over to them, and some common themes about collaboration, cooperation, partnership, working consortia, sharing resources, and leveraging what other people have already done. So yes, I think there is a great deal of optimism from what we're hearing from our members and from other partners that we deal with. So turn it to the panel.
Okay. I very much believe in manufacturing. I believe that we Canadian, we need to be value-added nation. So manufacturing is a part of value added. I had a meeting with Prime Minister Harper a few weeks ago, and I talked to him about the natural resources. I understand that we are very rich in natural resources, but we need to change these natural resources into value added through manufacturing. I am exciting, and I have an amazing industry next to me.
And personally, I'm very optimistic about manufacturing in this country. But I think the thing is, what all of us have talked about here is the tools are out there, but it really is up to everybody to embrace those tools and to use those tools, and not just, you know, because the tools are there, things are going to be great. No, we have to really invest in our companies, invest in manufacturing, and take advantage of the tools that all of us have talked about to be able to be competitive. So the tools are there, and for that reason there is great potential. But it's up to all of us to realize that potential.
Yeah, I mean, I agree. I think I'm excited about it. I mean, you know, Canadian inventiveness and engineering prowess has been proven time and time again. So, and we have world-class companies, right? And so, you know, and from another perspective, socially, we're a very progressive country. So we can take advantage of the diversity that's here, and you know, that really enriches this place, and that can enrich the solutions that we bring to the world as well.
Last word to Robert.
I'm excited.
Yeah. Well,
No,
I think
it's really positive. In general, I grew up and I still live in Windsor, Ontario. I was internationally traveling for 15 years, and admittedly, there's times I'd come back home from Guangzhou. I remember a few trips in China and India where I was really fearful for some of our manufacturing customers, you know, whatever they were doing. But by and large, the ones that are around today, they made it. They not just made it through 2008, 2009. They're really, really doing well right now. So, I think it's a pretty strong team of people.
Yeah. And I agree. I think the people who are here are confident. They do feel there's an important future for manufacturing. We have to be vigilant and make sure we get that message out to those that aren't attending the session, that don't really understand what manufacturing contributes, because I think there's a lot of work that still has to be done to deal with the psychological issues, to deal with the image issue, but I think there is a huge future for Ontario. And I think we also have to remember to focus on the positives, the assets we have, and not just focus on the negative that the media seems to portray about manufacturing. If you look at the OCD report that came out today, Canada is highlighted as one of the best places in the world on a variety of criteria, and I think we can continue to do that on manufacturing as well. And I'd like to thank you all for attending the session. Thank you for your support and what you're contributing to help manufacturing and advanced manufacturing grow in the economy. I'd like to thank OCE for putting together this important two-day event, particularly the session that we've just participated in. And most importantly, I would like to thank the speakers on today's panel who talked about why we should be proud, why we should have confidence, and the successes that they've been able to deliver at their individual operations. So please join me in thanking Jacek, Doug, Mike, and Robert. Thank you very much. And if I'm following my notes and instructions, I just now would like to call Jillian back to make final comments with regard to the session. Thank you.
You never want to really be the person that stands between somebody and their lunch, but it seems I am. Firstly, thank you so much to Ian and the other panelists. I really appreciated your insight. I think it really brought home the message that manufacturing is alive and well in the province of Ontario, and it's up to us to help refresh and revise that image and get young people engaged and energised about being part of that vision. We have a small token of our appreciation, so please don't run off the podium when you're finished. But again, thank you all for your participation. I'd just like to encourage you that after lunch, which will be held in Hall F, there will be a panel in here for connected and autonomous vehicles. It's very good that I got that out right. It's about the state of the industry and what types of partnerships and opportunities are available for SMEs in emerging markets. Saying that, thank you once again for coming, and enjoy your lunch and the rest of Discovery.